Hi everyone, you're watching the Space Channel. Advances in space technology over the past decade have significantly reduced the cost of spaceflight and made it more accessible. Thanks to this, leading government aerospace agencies and private aerospace companies have been putting far more satellites into orbit than before and preparing ambitious missions to the Moon and Mars. However, every space launch, despite its apparent benefits, also carries significant risks for the space industry. Here's the thing. As the number of objects in orbit increases, Earth is increasingly facing the so-called Kessler Syndrome, a kind of disease that may not make spaceflight impossible, but will make it extremely risky. The American astrophysicist Donald Kessler first predicted this scenario in 1978, when there were far fewer objects in orbit than today. It came after leftover Delta rocket stages, widely used by the United States to put payloads into orbit in the 60s and early 70s, started exploding in orbit. The blasts were caused by residual propellant that ruptured the aging, degraded rocket bodies, creating clouds of small fragments that, like shrapnel, could punch through and destroy any spacecraft or satellite, and in the process generate even more debris. Kessler calculated that the amount of debris in orbit would grow in a runaway cascade. Within 30 to 40 years, there would be so much of it that every spacecraft launch would face a considerable risk of colliding with space debris. After some additional time, the debris would essentially clog Earth's orbit, making spaceflight nearly impossible. This scenario became known as the Kessler Syndrome. Kessler's timeline estimates turned out to be off, but we're watching this syndrome unfold right now. After many launches, rocket components are left in orbit. Satellites sometimes fail and remain in their operational orbits instead of being boosted to a graveyard orbit at the end of their life. Additionally, collisions between small pieces of space debris occur constantly, and they are often too small to track. Some models estimate that there are currently over 300 million microscopic fragments in orbit. However, collisions between large objects are something we can witness in all their horror. In 2009, the first actual traffic accident in orbit occurred. High above Siberia, at an altitude of about 800 kilometers, the American communications satellite Iridium 33 collided with the Russian military communications satellite Cosmos 2251. The impact created about 1,600 large fragments, and who knows how many smaller ones. In 2021, the Chinese weather satellite Yunhai 1-02 collided with debris from a Zenit 2 rocket that had once launched a reconnaissance satellite for Russia. In addition, China and Russia carried out very reckless anti-satellite weapon tests. For example, the United States and India conducted their tests in low Earth orbits at about 300 kilometers, from which debris falls back to Earth within a few months. In 2007, China shot down a satellite at an altitude of 865 kilometers, where the debris will remain for hundreds of years. In 2021, a Russian anti-satellite missile destroyed its own defunct satellite in an orbit that intersects the International Space Station's path, putting the ISS at risk. The astronauts had to prepare for an emergency evacuation from the station, but fortunately, nothing happened, and the station wasn't damaged. However, the threat to the station will linger for many years. According to estimates, with the current number of objects in orbit, such satellite collisions will occur on average about once every 5 years, and the frequency will increase over time, especially given that projects like Starlink, OneWeb, and Amazon's Project Kuiper plan to put thousands, even tens of thousands, of satellites into orbit in the coming years. What's more, many are slated for orbits above 1,000 kilometers, from which they won't naturally deorbit for centuries. Because of this, these companies have already been asked to limit their altitudes to around 550 kilometers. The situation becomes critical once the collision rate reaches roughly 5 per year. After that, near-Earth space will quickly become so cluttered that most orbits will be too dangerous for flights. According to estimates, that collision rate is expected in the 22nd century, around 100 years from now. But with increasing spaceflight activity, it could happen sooner. However, fortunately, the onset of Kessler Syndrome for Earth wouldn't mean a complete halt to spaceflight. It would simply dramatically narrow its scope. Low Earth orbit, LEO, would self-clean fairly quickly, as drag from the thin upper atmosphere slows debris. Even in the worst-case scenario, it would clear in about a quarter of a century. The most dangerous orbits would be at altitudes from 800 to 2,000 kilometers. That's because they currently host a lot of hardware and debris, and they will take an exceptionally long time to self-clear, as atmospheric drag is very weak there. Among these polar orbits, those that pass over Earth's poles, deserve special mention. They're ideal for Earth observation and are therefore heavily trafficked, and they all cross over the poles, which significantly increases the likelihood of collisions between spacecraft in different orbital planes. This is precisely where Iridium 33 and Cosmos 2251 collided, and it's also where the highest possible impact forces, and thus the most significant amount of debris, are generated. The situation is simpler for medium Earth orbits in the approximately 19,000 to 24,000 kilometer range. In practice, these orbits are mainly occupied through navigation satellites, which aren't very numerous, and there's plenty of orbital space, so the likelihood of collisions is relatively low, and Kessler Syndrome doesn't threaten these orbits, for now. Humanity has filled geostationary orbit with satellites, as it's convenient for Earth observation or blanketing an entire hemisphere with a signal. But it's not all bad. This region is pretty spacious, and the Moon's gravity, which normally perturbs spacecraft orbits and requires fuel to counter, actually plays a helpful role here. When a satellite fails or runs out of propellant, those perturbations drive it into an orbit with an inclination of about 15 degrees, where Earth's slight asymmetry corrals debris near two equilibrium longitudes. Additionally, an increasing number of geostationary satellites are now ending their missions responsibly by boosting themselves into a graveyard orbit. According to NASA models, since 2007, there has already been enough debris in orbits between 200 and 2,000 kilometers to trigger a chain reaction and the onset of Kessler Syndrome, making such a future virtually inevitable. These days, various projects are being developed to clean up orbital space junk, but none of them can clear near-Earth space of the small fragments. At best, they propose collecting large objects or completely resetting certain orbits, a process that would take decades. We'll discuss orbital cleanup methods in a future video. Well, that's all from me. Thanks for watching. If you enjoyed the video, please hit the like button and subscribe to our channel. See you next time.